Check 2, 1, 2. There we go. Got some audio. Okay. This live stream is we got a bunch of questions during that video that just published, which is the off-grid camper van power system layout. So we had 2 questions, and I'm going to wait just a minute. So if you guys have any questions, go ahead and hop into the chat, and we'll answer them. I'm going to go back to the video and try to pick up the questions that were asked. We have one from Nick and then one from Daniel. So let me go find them. So I hope you guys are going to come in because the video ended on the premiere, and I was trying to answer those questions and cut off before I could paste the answers for you guys. Let's see here. Daniel had a question about 300 amps. So Daniel, if you hop back in here, maybe we can answer that question. And then Nick had a question on the Blue Sea Systems fuse panel. So I'm going to go ahead and drop a link to that product. Somebody's silent here just for a minute, guys. Just give me 1 second. Somebody's silent here just for a minute, guys. Let me get that one saved. So what I'm doing right now is I'm pulling up the van builder, the DIY van build cheat sheet, and I'm picking up one of the products that Nick had a question on during the video. So we just did a video talking about the power system layout in your van, kind of how to arrange everything, where everything needs to be as far as location, making sure there's enough room for everything to be wired up, enough room for, cable runs, stuff like that. So one question that was asked was, what company do I use for the fuse block? So this is going to be like the remote fuse block that goes somewhere else in the van. That way you don't have to wire everything to the battery area. You can actually move it to a separate area and then distribute it from there. So all the products that I use in the van for USB outlets, like a cigarette lighter, like 12 volt, stuff like that. Even the 110 volt AC circuits are Blue Sea Systems. Really good product, very high quality. They're all used in the marine industry. And if we go over here, I'm just going to, let me find this link. All right, Peter, so you got a question. So, Peter, were you asking the question about 300 amps being incorrect, or was that Daniel? That might have been Daniel. All right, so let's see what question you have. I'm planning on putting in a 3,000 watt Renogy inverter charger with two 200 amp lithium batteries from Amazon. Starting out with only shore power, do you know of a good diagram that shows wire size and fuse size? Okay, so we can look that up while we're working here. So I just mentioned Blue Sea Systems. So I'm just gonna have to hop on Amazon really quick. I'll add this link in for Nick. Blue Sea System. This is the you guys can see I'm over here. All right, how about that? There we go. I'm back. I got to redo this. I had a lapel microphone when we were all working on the system back here for the last week's live stream. So now I'm back on this big microphone. So the audio should be back. Let me check my phone here. There we go. Okay, we're back. Okay. Should be back. All right. Should be back now. Okay, here we go. We're going to go to... All right, so Nick, this is the Blue Sea System blade fuse block. What's important about this is it comes with a cover. So it comes with this plastic cover that goes over it. And the other thing you want to make sure it has is make sure it has a negative mounting location. So on these, let's see here. So in these boxes, you have a negative terminal up here at the top. I don't know if I can zoom in on this. No, I can't. So you have a negative terminal up top, and then you're going to have a positive terminal at the bottom. Sometimes, for whatever reason, these only come with a positive terminal. You want the negative terminal, so you can just run the two wires to this unit and use it as a kind of a hub for everything. So all your small amp or low amperage appliances or electronics, anything less than 15 amp, like 15, 20 amps. This thing, I get how high can this get? It's 100 amps max per block, 30 amps per circuit. So technically you could do like 30 amps and a 10 amp. But typically they're going to be much less. They're going to be in like the 15, 10, amp range. But I really like this one. This one is not on the list. I will add this. Where am I? Okay, let's get back to Peter's question. So he's using the Renogy 300 watt inverter. So if you go to Renogy, it's a website. They'll tell you this in the manual, but I'm going to actually show you where it's at in the manual because it might be hard to find. So if we go to inverters, and he has the inverter charger. So we got the 3,000 watt here. So we got the 3,000 watt. And yeah, let me know if you guys can hear me still. I can hear it on my phone over here monitoring it. So just give me a thumbs up if you guys can hear me. But we have the 3,000 watt inverter. So Renogy's kind of changed their site. Usually you could just scroll down and find it right here. But what they've done is if you scroll down, this menu pops up here. And so where the menu is, you want to click on downloads. Then you want to click on manual book. So when you click on the manual book, let me zoom in here. You're going to scroll down. Let me zoom out here. I'll zoom back in a second. So you're going to scroll down and you're going to go to okay, so you're going to go to page 13. So page 13, what we have is the model. So you find your model. So for example, Peter, you've got 3,000 watts. The recommended fusing is 300 amp fuse. And the recommended wire sizing, so this is wires coming from the battery. So if you directly wire the battery to the inverter, then the 300 amp fuse is what would be in the middle. Well, it doesn't have to be perfectly in the middle. But the 4-aught is going to be this size. Now, with Renogy stuff, I like Renogy. We talk about it on the channel all the time. I always triple check this. So I always kind of get like a second and third opinion. You should do this with anything in the van industry. So what I do first is let's do 4-aught wire max amps. Okay. Now you can do this for anything. It doesn't have to be this. I needed this to be zoomed in. There we go. So 4-aught welding cable carries 310 amps. So there we go. There's our first or our second opinion. So we got Renogy, we got this one. Let's get one more. So the next one I like to go to is we're going to go to Blue Sea Systems. This is gauge. Let's see here. Wire gauge chart. And then you're going to click on images. And then there's this chart right here. And let's click on this one. All right. So this thing is really cool. So I actually have, I don't know where I put it, but I have one of these that's printed and laminated in the shop. And it's just, just a quick reference. Some of these I have memorized, but I always refer to this before I actually cut and crimp, even though I've done it a bunch of times. So what you're going to do is, in a van, the length of the wire is not that critical as far as a voltage drop goes. However, I have to walk back what I just said, because on Thomas's van, and this is one of those things when if you do everything by the book, there's kind of one more thing that might be sensitive to a certain product. So for example, we put a Vitrifrigo drawer fridge in his van, and it was only consuming, actually now I kind of forget, but the amount of amps that it was consuming, I measured it and I sized the wire to the amount of amps. I oversized it a little higher than the amps that it was consuming, just like a typical electrical circuit. What happened with the fridge is every now and then there was like an intermittent error, and it was a voltage error. It was saying low voltage, but I was wondering, I measured the batteries, and we still had like 13.1, 0.4 volts. And so it didn't make any sense. And I said, wait a minute, let's look at the fridge and let's see the voltage drop. The voltage drop of the fridge was around 12.8. And when the van got hot and everything was under load, it was dipping past that threshold that the refrigerator was happy at. So I went and I retraced the wire run because we had wired so much stuff in his van. And this happened to be the longest run because we had to go from the passenger side of the van. We had to run it all the way down the passenger side. We had to run it up the wall. We ran it across the wall and then down to the kitchen galley. So where the kitchen galley sink was, that was where all the other wires terminated. However, we still need to go to the bottom of the van, towards the driver's seat, back, and then up. So that added almost another 10 feet. So believe it or not, that additional 10 feet did make a difference, just a hair of a difference in the circuitry to make the fridge maybe once a month have a error. So what I did is I pulled it out. We went back to the manual. We translated the manual because the manual was let's see, what is the Vitrifrigo? Let's see here. I'm looking it up on the computer real quick. I think it was Italian. I think it's an Italian fridge. Anyway, so I went through and I Google translated the Italian side of the manual, not the English version. And on the Italian side of the manual, it had a current rating for the fridge. See, what was the current rating? It was something like 30 or 40 amps for a 12-volt fridge. And I could never, on my 12-volt, what am I trying to say? It's late. Okay, so on this guy, right, this is what I use to test on my circuits and find out the voltage draw just to make sure that everything's within spec. So I used my voltmeter on it, and the blip of surge from the compressor turning on, because it's not a soft start compressor, that the slightest blip did a voltage spike, and it was enough to, in that just instant, create an error on the circuit board. It was enough to run the fridge, no problem, because the fridge it was a very, very efficient fridge. However, I had to upsize the wire gauge to what did I use? 10 gauge? I think I went to 10 gauge. And all the problems went away. Everything got fixed. It hasn't had a problem since. So, long story short, or long story long, the reason that I first said feet doesn't really, the wire length doesn't really matter in a van is because a van is, it's no more than like 20 feet long that you're going to use of a cable. However, in a particular situation with a particular manufacturer and sensitive electronics, yes, it can make a difference. So the circuit length over here does make a difference in those very rare cases. All right, so moving on. Find out how far away your wire is going to take from the unit to the battery. Okay, that's going to be your feet. And as long as you're between 0 and 20, you can use this top line right here. So 0 to 20, if we are going to consume, and you see how this runs out at 200 amps? So Peter, stay with me here. So the 200 amps, we've got a 2-aught gauge wire. But when we look up online, we have found, where's the other? We go and search our 4-aught, we know we have 310 amps. So you can kind of understand that of where this goes. Now, wire gauging is very confusing. You kind of have to think backwards on this. So the higher the number, the thinner the wire, and the lower the number, the thicker the wire. So we have all this down here. For example, in the video that, if you guys watch that I just uploaded, we have a 50 amp DC to DC charger. So for 50 amps, we're going to use a 6 gauge wire. And the 50 amp, you can see, is safe up until about 70. And then you need to go up to a 4 gauge. The number goes down, but the wire size goes up. And then it continues. Where it gets weird is once you get from 4, 2 to 1, it turns into 1/0. So like the O or the 0, 2/0, 3/0, 4/0. And those are real big, thick cables. Let me pick one up. All right, so let me go back to here. So this is 6 gauge, and this is 2/0. So you can see, the difference. So for example, this is going to come from my alternator of the van. Well, technically from the battery terminals of the engine batteries. But this one is what I'm going to use to connect my 12 volt 100 amp hour batteries together, is this one, 2/0. But going from your, so for example, we're going to connect that to the, so let's see if I can finish up Peter's question here. So it says you need a 4/0 cable for 300 amps. This is 4/0. Yeah, so the 4/0 is we're gonna take that from the Links distributor, for example. So we'll go from the batteries to the Links distributor, and from the Links distributor to the inverter. And then what's nice about the Links distributor is this 300 amp fuse right here, we can put in the Links distributor. Because if you look the Links distributor up, and I'm gonna draw this here in a second. I'll draw this out. So the Links distributor, I forgot the amp max. That's what I'm looking up. Let me type it up here. Let's see, Links. Yeah, 1,000 amps. 1,000. So you can have 4 250, or you can spread it out. So Peter, for example, that box that I showed in the video, this one, what you would have is going across here. So you'd have your batteries coming in on this front side, and then you'd use a mega fuse coming across this, and it would be a 300 amp rated fuse, and then you would go to your inverter. So that's where I would put that. All right, that was a long answer. Hopefully that helped. I can also draw it if you would like me to. Let me see if I can find an image. All right, I'm just referencing this. This is not an example of mine. Okay, that's not a good example. Let's not look at that. Yeah, I might draw it because these are a little overcomplicated. So let's go to the drawing pad. Hold on, I can crank it up here. So I believe, yep, I'll do a drawing. So Peter asked, what size wire from the shore power plug to the inverter charger, and do I need a fuse in there? So there's a couple ways to answer that. Shore power plug, you have different ratings. So there's like 15 amps, 30 amps, 50 amps, and it depends on this box right here. So this is the inverter charger that's going in the van. Peter, you probably have like the blue one. This is the new gray one. There's nothing. The only difference is this one has a integrated Bluetooth inside. So there's a setting on the panel, but I will draw that. I will do a drawing here in just a second. There is. Okay, let's go back to Renogy. There is a. Let's see if I can find it. So there's this digital panel right here, and you're able to. I'm going to explain the concept of this. This is the first time I've used the Renogy inverter charger. So I haven't gone in to do the settings, but I've read enough to understand what I need to look to change in order to size my wires when I get there. So I'm going to explain to you how I'm proposing to do it. And then hopefully by next week, I can actually show you how I did it. So there's a screen that that's gonna come on the unit, and you want to find where you are adjusting the shore power incoming amperage, because it's adjustable. So it's like shore power amperage configuration, something like that. Let me just see if I can search this. So you can do Control F on some PDF documents, and then you can search the PDF. So I just did Control F. I typed in shore. So this little wave means shore power is connected. So we're going to keep pressing enter. This inverter charger will automatically switch from when it senses shore power to be charging from it. But we want to figure out how to set shore power. So give me 1 second. I may find it now, or I may find it later. Except there's a way for us to control how much amperage is going is what's being used. So again, long story short, you want to size the wire of your shore power outlet that goes and connects to the inverter charger to handle what you're anticipating using. So if you're going to plug it into your house and you're only going to use a 15 amp or a 10 amp outlet, size it for 15 amps. But sizing it higher is not going to hurt anything. You don't want to undersize it. So you don't want to size it for 10 amps and then use it for 30 amps. Very dangerous. Don't do that. Now, don't quote me on this, but I believe there is like a bimetal overload fuse inside the inverter charger, so that if it gets too much, it'll disconnect itself. But you can always add a inline fuse. Okay, let's see if I can find this really quick here. Let's see, surge. Okay, where is this thing? Okay, I'm gonna go to the drawing. All right, we should be back. Yeah, I was on the lapel mic last week, so I turned all my settings to lapel. So we should be back again. We should have audio. I can see it on my side. So yeah, just give me a thumbs up when you guys hear it. Okay, here we go. So we got the inverter charger. We've got. So let's do shore power over here. Okay. So the shore power is going to be line, neutral, and ground. So you're going to have 3 wires. And then this needs to be rated to your what you're going to have: 15, 30, 50. So let's just go to Renogy. Let's just see what the max amperage is. Okay, so over here, what we're looking at is on Renogy's page, we're going to talk about the AC wiring, and they have a little diagram here showing that there is the output, the AC output. So this AC output, so I'm going to do this in red. What's wrong with my colors? Hold on a second. Hold on 1 second. I don't know why this is messing up. I'm having technical difficulties today. Come on. Is it going to be red? No. All right, hold on a second. I got to exit out of this. This thing's messed up. See, there are my colors, but when I let go, it makes them disappear. All right, this is... All right, guys, we're just going to have to use black. All right, so this side we have AC. This is input. So this side is AC input, and then this side is AC output. I don't know why I'm using the slash. Okay. This is not perfect, but this is just more illustration. So I'll do little arrows here so you guys can kind of see where how the power's flowing. And so this, you know, think of this as like your household plug over here, okay? And this is the power's going in. So this is the flow's going this way. Your AC output from the inverter charger is going to go to a box. So this box, there's two different kinds of boxes. So this is your AC panel. This is not 12 volt yet. We're only talking about AC here. So mute this. Blue Sea Systems, 110 volt breaker. And we want this one right here. So this is the one that I use. Blue Sea Systems, 120 volt AC 4 position. It's very compact. You got breakers like this. They're kind of like the ones in your house. Hold on. I know it's not on the screen. Stay with me. So this is what it looks like. It has breakers, okay? And then what you're going to do is let me search an image. We're going to keep this simple because this is technically complex. I can't. I gotta get some software here so I can help you guys zoom in on these images. Let me just save this image. There we go. Perfect. Okay, cool. Check it out. All right, so this right here is this. Okay, this right here. So you have your microwave, your outlet, your water heater, maybe another outlet. This is like your house main breaker. Okay. So over here on the left, you've got, this is like a plug that plugs in your house. So this is shore power. Doesn't matter if it's 15 amp, 30 amp, or 50 amp. This is like plugging an extension cord into your home or like the RV park. The ratings are what is specific to what your inverter charger can change. It's also specific to the gauge of wire that you're going to size to get the power from the RV camp or your home into the inverter charger safely. So once it's in the inverter charger and it turns into charger mode, hold on a second. I'm leading you guys astray. We're going to have AC output, and then we're going to have 12 volt output. Okay. And that 12 volt output is going to go to, stay with me, guys. The 12 volt output is going to go to your this is going to go to your 12 volt fuse panel. So kind of, this is what Nick was looking at earlier. So these are like your blade fuses. You know, max, maybe like 10 to 30 amp. So you have two. You have your, man, I wish I had some colors over here. Why is it doing that? Anyway, so you have your 12 volt fuse panel, and then you have your AC output. You got your AC breaker. Okay. I know these are not different colors, but this one right here, hopefully you guys can understand that this right here is just AC only. So mains power, 110, 120. And then down here, this is 12 volt power. So you have two different runs. These are great questions, guys. These are great because I see where this can get very confusing. All right, give me 1 second. I'm going to try to fix this because I need the colors to help teach you guys this thing up here. I don't know if you can see my this color thing. I drag it and I need these colors right there. But when I let go, it resets everything. Hold on, give me 2 seconds. This is crazy. I have to make up my own colors again. Technology is supposed to be easy, right? This is ridiculous. There you go. Maybe those are better colors anyway. Okay, I need to erase the 12 volt thing because this is getting very confusing. Or I'm making this confusing. Okay. All right, here we go. So this. Okay. There we go. Okay, here we go. So the arrows designate the direction of the power coming in. So your 110, 120 volt side of your inverter charger, this side is not charging your batteries, okay? It's not. This is only operating through the breaker, your 110 outlets. We're going to get to the 12 volt here in a second. All right, stay with me. We're doing good here. Okay, so this side right here, remember 110, the inverter is taking power from shore and it's directly going through the inverter charger just straight, okay? Nothing's being converted, all right? Boom. The next thing, so let's get rid of this. The next path is the charger part of it. The charger part, so there really needs to be like a slash here. Inverter slash charger. I think inverter charger is confusing. It's an inverter and it's a charger, but the charger is on the 12 volt side. Okay. So what's happening there is we've got a negative and we've got a positive that's connected. And you can kind of think of inside here, there's a part that is the charger. So it's like a DC to DC charger. But what it's doing is it's taking the shore power and it's converting it to 12 volts. Not technically 12, it's enough to charge. It's a higher, like maybe 14.6 to charge a lithium battery. And then that is going into, so let's see here. So like on the links, so you'll see this later when I actually do this in real life. But this right here, if you watch the video, there's fuses in here. So inside here, think of you've got 4 fuses. big chunky mega fuses, right? So you got like the 300 amp for your inverter. You've got maybe the 80 amp for your air conditioner. So let's just say this one is the 300. Good Lord. So let's say like this is the 300. Come on, pin. Say this one is the 300 amp fuse. Let's just say like this is the 80 amp fuse for the air conditioning. And then here you have these two wires are coming off of, I hope this does not confuse everybody, but these are being connected to the Links distributor. The reason I put the two terminals over here is because, okay, here. I really gotta make sure I simplify this. Okay, you've got the negative side of the Links distributor. And remember, Links distributor is nothing fancy. It's just a big old bus bar that happens to allow you to put fuses across of it, for convenience. Because you technically could have just two bus bars, a negative and a positive one, and then have, 1, 2, 3, 4, like 1, 2, 3, 4, branched out fuses. So what's happening is right here, there is a post, right? That's got a bolt on it. And we got a post over here. It's got a bolt on it. And we're connecting the inverter to, actually back up. Stick with me, guys. This is hard when I don't have it pre-done. I'm laying this out so that you guys can reference this like forever. So I need to make sure I do it right. So down here in the bottom, you need to make sure you have a negative. This is your ground. So this is your ground post. So let's say right here, this is our ground post of the van. And so what we have, this is, we'll do we're making this one negative. So this wire is negative, and this top one is positive, and I'll show you why I flipped that. I did it so that I can show you that coming off of here, we are going and we are connecting to our negative ground. Okay, so that's our ground. So the inverter is coming to ground. We got the Links distributor coming to ground. And then what we're going to have next is we're going to have our batteries over here. We're just going to do one battery so we don't get confused. So we have our negative terminal. We've got our positive. Okay. All right, you guys give me a thumbs up here if this is working. If this is helping. I'm going to keep going. If you're wondering what the this little black circle is, that is like a terminal post. But if that word freaks you out, just ignore it until we're done. Okay, let me get my face out of the way. Okay. Woo! Brain dump here. Okay, this is the battery. Here we go. This is the battery. So what we're doing is the battery comes in, and these are just posts. So all this is I mount it here, but I'm showing you this so that you can kind of see how it's connected so it doesn't look too crazy. And so for example, when the AC from the shore power is coming in the inverter charger, so kind of forget the word inverter. Well, no, don't forget the word inverter. The inverter part is when we're taking the 12 volts and we're inverting it. We're taking 12 volts and stepping it up to 120 volts to run our appliances. Okay? So when we're running off of the battery system only and not shore power, just the battery is only supplying 12 volts. Now, I know technically it's 14.1 or 13.7. I know that. We're just going to say 12 volts just to be simplified. So the battery is 12 volts. Okay. Just for example purposes. So 12 volts is coming in. Okay. Don't think about this right now. Like, don't think about that. So 12 volts is coming in. When we turn our inverter on, we take the 12 volts, and the inverter is going to step it up to 120 to power the stuff in our van. Now, let's say we're at an RV park or we're at home. We need to charge the batteries. So what we do is we plug it in to shore power. There's a switch inside that changes over and turns it into the charger mode. And now it takes the 120 or 110, 120. Let's just keep it at 120 volts. It takes that and it steps it down to the 12 volts. And yes, I know it's technically the charging voltage. So let's say 14.6 for lithium. And it comes down and it goes right here to this post or wherever you're at, and then it goes to the battery and begins to charge it. So give me a thumbs up if that makes sense. So once I see a thumbs up or it's helping, we'll move on to the last part, which is how this gets distributed through the distributor to other things. All right, so why I hear feedback, I'm going to use the green color to show one more time how it works. So we plug it in, comes in the inverter charger, and if it's 110, 20 that we're using, and we're not charging the batteries, we're just going to go straight through here. Boom, we're going to, make some popcorn in the microwave. All right, boom, straight through. But when it's charging the batteries, we're going to come through, and we're going to convert it, charge the batteries. When we're not, the last part is when we're not hooked up to shore power. So this is, when this is off, we're going to take the power from the batteries. We're going to step it up and make popcorn that way. So that's pretty much what it does. This part is how you are managing and keeping safe your other charging sources. So right here, I could have my inputs for my my fused inputs for my DC to DC and from my MPPT. So like my solar. And I can have them fused here. And so even though I'm coming out here, I can still go in because it's just the way electricity works. So I can still charge my batteries this way through my charger. But not only can I, this is the wild thing about electricity. So I can still charge while discharging. Okay? It's wild. So that's, I completely understand when it gets confusing and you're really worried about, you know, blowing something up. But remember, if you have it fused, at the end of the day, it is 12 volts. You know, you're not, on the 12 volt side, you're not working with high voltage necessarily, but on the AC side, you are. So that is dangerous. So the 12 volt, you know, you do have high current if you're working on the inverter side, like up to 300 amps, for example. AC side, you don't have the current. It's the high voltage that's dangerous. And let's hop back over here to this one drawing, and then I will take more questions. So go ahead and get those questions going. I'll probably end this here in just a few minutes. But over here on the computer, this right here, so we didn't talk about this. So this right here is this. So this is the wiring. So we might do this in a future video, but this is the schematic for your AC side. So you have your ground over here. That's going to be the same as the 12 volt circuit, which that can be confusing. And then you're going to have your neutral over here. And then you're going to have your hot up here, your line coming in. And once you have those three connected, then Blue C is going to give you these four screws, and each one of those is going to be the hot leg for each of the AC loads. But that might be for a different video. I know this is getting a little heavy right now. But yeah, happy to talk about this. We got to do it in the van, hook it up anyway, so it'll be in a future video to show you how to do it safely. But yeah, that's a pretty good segue from the video that launched this afternoon. Let's see, who else we got watching here? Yep, so Peter, I'm glad that helped. All right, so let's see what else here. I think that's about it. Do I have anything to show you guys? All right, I will stay on here for about a couple more minutes and see if any questions come through. I'll do my little spiel here. If you guys haven't checked out, if there's anybody new that's watching, we have a Van Builder cheat sheet, and I talk about this a lot because I really think it can help anybody. If you go to vanbuilderhq.com, you can sign up for it. You may be asking, what is this? What's the Van Build cheat sheet? It's essentially an Excel sheet that I put together over 250 curated items that I've put in vans. So for example, we were just talking about the Renogy 12 volt DC to DC charger. So boom, right here, we've got the link to Amazon for that charger. We've got all of the fuses. So remember I was talking about Blue Sea System Mega Fuses. So I've got a link to the Blue Sea System Mega Fuse in the document. And then the most important thing, other than the fasteners and insulation, roofing, solar, is the tool section. So tools are very helpful. All the stuff here, all the crimping, heat shrink, and hydraulic crimpers are all here that I use to build the vans. So when you get to that point and you've already gone through your whole circuit, you got everything ready to go, and you're getting ready to make the wires, and you need to strip, crimp them, and then heat shrink them, all that stuff is on this list. So you guys can just click away, and it is the stuff I'm using in the shop right now. So the tools on there are the stuff that I'm using. So if you think it's going to be helpful for you, which I really think it'll really help you out, especially if you are DIY and you need some help just getting a kickstart and you don't want to waste money on searching around for tools, maybe buying the wrong thing, and you want to save time, it's all in one place on this sheet. You can go to vanbuilderhq.com and pick this up. And I'll just quickly put the link in the description here. And you guys can click on it and download the sheet. All you got to do, it's completely free, 100% free. Just put your name and email address. It'll come straight to your inbox. You'll get this form, and you can really just do whatever you want to with it. But when you go back to it, I will be updating this throughout the year. Some more products will come on here. For example, Nick, earlier, we were talking to him, and he was looking for a fuse panel. So one of these Blue Sea System fuse panels. There's a new one that I like. I didn't put it on here, so I'm going to go in here. I'm going to update the list. But yeah, DIY van build cheat sheet. Click on that link. I really think it's going to help you guys out. And I appreciate you watching the live stream, asking the questions. Definitely here to help you guys out with your DIY build or really anything, van related. We're building that, power system out. Everything's looking really good. Probably next week is when I'll actually start cutting the wires. I need to measure a couple things. Need to get some more like 10 and 12 gauge wire for the other circuits because it's getting exciting. Once I get everything laid out and I know where my wire runs are on the floor after doing all those cutting for the shower and the flip and fold seat, we're actually going to get to a point where we can take the floor out, prep it, paint it for the epoxy, and then put the lawn sill on it. It's really going to start to look like something. But we still need to cut out the hole for the shore power and have the trunk that comes down for the Dometic RTX 2000 air conditioner. So that should be coming, maybe be coming at the end of this week. The air conditioning unit. Yeah, things are going to happen quick. It's going to be exciting. So you guys actually see it unfold. So get your questions ready to ask as we go along in this journey. And I really appreciate everybody watching the live stream, checking out the video that we just published today about off-grid power systems, kind of how to help you guys design your layout, where to put the batteries, where to put the inverter charger. And it's really how I did it. There's multiple ways you can do it, but if you want to do it how I did it, these videos should help you out, as well as, some of the cheat sheet stuff to help you with the parts. But that is going to do it for our live stream tonight. Again, thank you guys so much for subscribing, checking out the channel, checking out the video that just launched today. And I look forward to more comments and questions in the future. And we'll see you again on a future live stream. Oh, one more. Hold on. Let's see. One more item I'm looking for is a heavy-duty door slide. Bottom mount. All right, Peter, let's do it really quick. So, bottom mount drawer slides. Let's go find one really quick. So let's hop over here to Amazon. So these drawer slides, everybody knows that these are the kind of the side, but you were looking at the bottom mount. And I can understand why, because the bottom is going to make it a little bit easier to mount. However, those are kind of tricky to find. Let's see if this might be something close. We're kind of impressed with this stuff on Amazon. Let me click on my face. Let me see which one I ordered recently, because the company was very, very good quality. So let's try to stick with the same company. Okay. So I just ordered this company. It's it's some crazy name. Let's see. Let me share it. Okay. Now this is not the bottom mount, but since we're live here, let me show you what it looks like. So this is the 500-pound version, and this is I'm using the 18-inch version of this. So this thing is beefy, but this 500 pounds, it's extremely overkill. I just got it because I'm using this so that you can slide out the toilet. So this guy, and you can use it while sitting on the drawer slides. So it'll withstand 500 pounds. You want to make sure that you get the locking version. So the locking version has this tab. Okay. And so when you push down on this tab, it unlocks this channel. And then when you get to the end, it clicks. So you can kind of see. So it'll lock in 3 different positions. So right here it's locked. And when it opens, there's a click right there. There you go. So that's locked out at full extension. And then you come back in. Now it's not locked, it'll come out, but see, watch, it'll stop right here. And then you push it in and it locks back in. Actually, it's 2 positions. I thought it was 3. This guy is beefy. Okay, that is the side mount. But you want to make sure you have it with the lock. And then you can click on here. Hold on a second. There we go. You can click on here, make sure it's with lock, and then up here you have the different links. But this brand, this weird AOLI Aloe Sheng store, the quality from what I bought is good. Now, for the mounting that you wanted, like this, I do not know of one that has that high weight rating, so I'm not sure. If I were you, if you maybe using 80/20 or something like that, if you can make your own side to mount it to, that would be the way I go. Find something that you can mount it to. I'm going to look real quick before we get off the stream. Yeah, because they are drawer slides. They are meant to be, in like mounted to a drawer style fashion. So I know what you're wanting to look for. It's something that may be difficult to find. So here's this one, but it's not locking. All right, let me change my search. So let's go under mount. Yeah, the undermount's going to be hard, especially to get locking. So see if, you don't have to get 500 pounds. Like you just said, like a 260 pound, that's going to work perfect for you. No problem at all. It really just depends on what you're doing. But my go-to is to make sure it's a locking drawer slide, and you want full extension locking. Because what will happen is if you don't get full extension, then your drawer or shelf or whatever you're using is only going to come out, halfway or something like that. So you want to measure the back of the shelf or drawer, wherever you want that to come out to. That's the distance of the number. All right. All right, guys. It is almost 11 o'clock Eastern Standard Time, so I'm going to sign off. If you guys have any more questions related to this, put that in the comment section below, and be happy to answer that in a future video. I think we got like 4 more questions that came up on the comments for the channel, so I'll work through those, see which ones I can answer. I'll do that tomorrow. And then, hopefully... this was an unplanned live stream, but it was very useful. We got a lot of questions, a lot of participation. Nick actually mentioned that ABYC has a chart. All right, we're gonna go back. We'll go back over that later in a different stream. Got to hop off here. So it's possible that the power system, I may have the 80/20 cut, and maybe we'll do a live stream on where I get with that. But once again, check out vanbuilderhq.com. Sign up for the DIY Van Build cheat sheet. Subscribe to the channel if you're not subscribed yet. Throw us a like on this video if you liked it, if it was helpful to you. Share this with somebody that you think might help out. And once again, keep those comments, questions coming, and we'll see you guys in the next live stream.